Greetings, this is Charles Darwin, and we are in the rain shadow of the Sierra Nevada mountains. You see them behind me. These are the high Sierras caused by the stresses and strains of geological activity, the movement of the Pacific and North American plates. These are the highest mountains in the lower 48 states. Mount Whitney is to the south, so you're not actually seeing it right here, but these are some of the highest mountains. Now, the evolutionary interest of this location is that the Sierra Nevada mountains create what is known as a rain shadow. The rain comes from the Pacific, which is over the range of mountains there, and creates a dry shadow on the leeward side of the mountains. As the moist wind comes in from the Pacific Ocean, and then it rises to the top of the Sierra Nevada mountains, the relative humidity increases, and there's a lot of rain and snow. By the time the wind comes over the mountains, down into the Owens Valley Desert below, and up to the White Mountains, where we are right now, the relative humidity and the absolute humidity have both decreased. And as a result, there's not as much rain and snow, so you have much drier conditions. Now, the evolutionary interest of this is that it creates localized microclimates. And you have species that have evolved in those specialized microclimates. For example, down in Owens Valley, which you can't actually see from here, but you can see a little bit on the slopes, they're desert shrubs, but the desert shrubs are not the sagebrush that are common in Nevada and Utah. Instead, it's the shad-scale scrub, several species of shrubs that are found here but not found in the Great Basin Desert. Also, the pinyon pine trees, which are the pine trees that grow in the driest conditions, at least for pines. And you would think that this is the same species of pinyon pine that you would find throughout much of Arizona, New Mexico, Utah, etc., but that's not true. This is Pinus monophylla, which means that it has only one needle per cluster, unlike other pine trees. Whereas the most common pinyon pine found in Arizona, New Mexico, and other places is Pinus edulis. So what we find here is specialized species that have evolved in these locations as a result of the rain shadow that has occurred here just in the last few million years, few dozen million years, since the Sierra Nevada mountains have risen. These are relatively young mountains. And that's the evolutionary interest that you find here. And it's very inspiring to come here. Just upslope, I'm going to visit and have a video about the bristlecone pine trees. I wonder how many people go along Highway 216 down there and look at the pinyon pines and think, oh, there's supposed to be bristlecone pines around here. It must be them. But the bristlecone pines are of great evolutionary interest, not only because they are the oldest pine trees, but also because they are found at just a very specialized location up the mountain there. You have to go clear up to the cove before you can even see them. And that's where I will be next. I don't know whether I'll post that video before or after this one, but this is Charles Darwin. Tally-ho, and amen.